My name is Ron Britvich. 25 years ago, I worked for a company called Worlds. We developed a virtual reality platform for sort of like the early MMOs, and we did took that as far as we could take it, and I said I didn't really want to work on anything else new until there's some major new technology that comes out, and what we're seeing is coming soon is the concept of AR glasses are going to be available, and that it's probably a year or two away, but it's really a nice new way to see the internet, because the internet today, you can't really see it in your world. You have to go to a screen to see it. And so we wanted to develop a platform where you can put the internet into your world. You can see it, you can touch it, you can feel it. You can, eventually you'll be able to smell it and whatever. So this is the journey that we took to create this, and so the problem we have is we're trying to create a social AR platform, and we want it to work with handheld devices and AR glasses that are coming, and it's a pretty complicated problem to create a distributed computing platform that can handle the kind of growth that we expect it to have in the future. One of the things that we want is obviously something that's very scalable. It also has to be secure, if we're doing transactions and things, and we in an AR type environment, we need very low latency. It has to be able to handle tremendous number of messages per second, and we also run in what's called an authoritative environment, where the services are the final say, and they tell us what they make sure that users can only do what they're authorized to do. And we're also very interested in the location independence of the services, and we want a system that's very resilient, self-healing. We don't have to just constantly be monitoring it. So the first thing we had to do is choose a client platform, and right now the major clients for AR are Apple's AR kit. Microsoft has the HoloLens, and they have a whole development kit around that, and then Google has their own AR core development kit. The problem is we don't want to write specific code to each of these different platforms, so we chose Unity. It's a VR AR type environment platform that has a thing called AR Foundation, and what it does is it unifies the platform code so that we can write one set of code and it works on all these platforms, and as future platforms come out, it should work with them too. Next thing we had to do is choose a networking platform, and so we looked at Unity's networking. They have an older system called UNet, and it's only designed for up to about 24 users, because it's peer-to-peer. It uses UDP. It's also deprecated. They don't really want to support it anymore. So they've been working for the last couple of years on a new thing called their netcode, and it's designed, you can get up to like 500 users, but it's not available yet. They've been talking about it for quite a while. So it's not going to be a solution that we could use. And 500 users also is not the kind of numbers that we're looking for. We're looking for millions of users. So what we took a look at gRPC and found that it could do most of what we wanted. We actually did the first implementation using gRPC. And it worked pretty good until we started facing some of those scaling issues. And as Derek said, the problem with some of these technologies is it's like you're calling your home phone when you want to call your cell phone, and be location independent. And that is a problem with gRPC. You're constantly plugging in IP addresses, and it doesn't really scale out either easily. You can't just start creating extra servers, to manage the load. Not particularly resilient. If one of those servers go down, you've got to write all the code to get it up and running again. And so it doesn't really self-heal. So then about 6 months ago, I came across NATS for the first time, and I was like, well, this looks interesting. Watched every video I could get my hands on from NATS, and realized that it actually solves some of these really complex problems that we were facing. Is it does have that location independence. I'm calling my cell phone, and that's exactly what I want. I can scale it out real easily, and it's designed to be self-healing right from the get-go. So I created an architecture topology like this. And so here, what we can do is have, millions of clients appear talking to a cluster of NATS servers. And for example, this might be on the United States side of things. And then those talk to these services that we have. There might be an avatar service. This is to keep track of where people are at. A property service. This is the objects in the real world and where they're located. A citizen service for managing identity and rights that different users have. And then on the other side of the globe, we can have the same thing and then create a supercluster across these continents, and then the various services can talk to each other and through this supercluster, and they can keep, for example, the citizen database up to date across the cluster, and the property and things like that. So this I was like, wow, this is fantastic, because now I can have very low latency here. I'm now using subject-based, PubSub, and many of the difficult problems just went away as soon as we did this. So we had to come up with, the set of subjects that we want to communicate with on, and so we have the citizen service, the avatar service, and the prop service. And so we created just some simple subjects. So citizen.immigrate, when you wanted to immigrate into the system or log in an existing user. The avatars, they need to tell their pose and say things to other people and select objects and things like that, and make offers. Like a bot may need to offer, various choices to a user. And then on the property side, you need to be able to add things to the world, look around at where you're at, move and remove objects from the world. So the world can be multiple things. So an example might be a real estate world. This is homes for sale. And so you might add various items about a particular property that's for sale, descriptions about it. As you're walking through the house, you can actually see things that are left by the realtor to tell you about features of the home, for example. You could have other worlds too, maybe a location of different garage sales and what kind of items they have for sale. So you could quickly take a look at that. Maybe you're doing an infrastructure type app and you want a database of all the potholes in your city. That's the kind of different worlds you can have. And the design of our platform is that you can be viewing multiple worlds at the same time and interacting with them at the same time. But what's important is to not have the clients completely overloaded with things that are happening way far away from them. So if I'm here in California and I don't really care what's happening in Paris, France, someone's building something at the Eiffel Tower, for example. I'm only interested in what's nearby me. So we have this concept of cells, and the way we do that is using NATS, we subscribe to just the cells in our immediate neighborhood that we're interested in. So let's say we're at Disneyland, for example. This is a map of Disneyland. This is the very center of Disneyland, the hub. And let's say we're standing here in the southeast corner of this hub. What we would do is subscribe to the latitude and longitude coordinates of that cell to 1/100th of a or 1,000th of a degree of accuracy. So that particular cell is 33.811 north and 117.919 west. But we also subscribe to the other 8 surrounding cells so that we could see things in the distance as we're walking through there. And with NATS's subscription model, we can easily just indicate what our area of interest is by subscribing to a subset of all the cells in the whole world. So if I'm in Disneyland, I'm not going to hear messages that are happening in Paris, France. I'm going to just hear what's happening in my local space. So the services, they subscribe to, depending on the service, to various messages, and we also use queue groups so that as the load on various servers get too high, any one of the queue group can handle the message. And then like a property server, they would subscribe to as things are added or people are looking around. They also will publish what changes that have been approved by the authoritative servers and publish those events. The clients will, again, subscribe to just cells that they are interested in, worlds and cells that they are interested in. You can see that. And then one of the next things we had to choose was what kind of protocol we wanted to use. We ended up looking at various ones such as JSON and protobuf. We ended up choosing message pack for C# with LZ4 compression. You see it has one of the fastest serialization and deserialization speeds, and it also has one of the smallest sizes for messages. So that ended up being good. To define the protocol using message pack, all you have to do is define these structures. So like, for example, here, if I'm adding property and I need to define this event, I just give it 3 keys that I want and set the things up. And then there could be other things like an add request, an add reply. And you notice there's a property in here. These can be defined also as even as an abstract class, where you have the base class, and then you can use a union and extend that class to create more complex objects. And so to use this in Unity, it's pretty simple. All you have to do is call into our services SDK, and you'll notice one statement I wanted to highlight is this don't destroy on load. When you're using Unity, you want to make sure to call that when you start up. The awake is the way you start up. And what that does is make sure that as soon as I load another scene in my AR experience, all of this setup doesn't go away. If you don't do the don't destroy on load, as soon as you load a new scene, the whole system will fall apart. It will just lose the connection to NATS. And then this is a simple, connection up to NATS that is very typical. To call a service, you just, for example, new up a PropService. You can add like an event handler. Like when somebody adds a piece of property, you want it to call this event handler. And if you want to add property, you just do that, and you notice it's using NATS's asynchronous system, where you can just await on that, and it's very simple. There's no callback hell or anything like that. I use async and await in C#. When you call into it like a PropService, what it does is it just takes the parameters that we have. It creates one of these event protocol objects, and then it publishes it out using NATS. As you're creating an event handler, similar. If you're adding requests, again, is similar. And these call in finally into the asynchronous messaging handlers for NATS. So here I'm subscribing asynchronously. Here I'm publishing using the NATS connection. And here we're doing an asynchronous request. And we're doing, this also is doing the serialization and deserialization as the messages are coming in. So it's pretty simple. And then to write a service, finally, this doesn't even have to be in Unity. It can be just regular C# code. And in fact, it could be even other languages. You just new up one of these prop services. In this case, I'm subscribing to everything, all the prop messages. And then as a request comes in, I just have a handler here. Here's someone wanting to add property to the world, and I just process it. And you notice here, I send it back to all people that are interested. And then I tell them that, yes, you successfully added something to the thing. So that's it. That was our journey creating this world's augmented reality platform. We're so glad to have NATS that it helps us get over all these different problems that we're facing with the other solutions. And if you're interested in developing services or bots or different applications for WARP, we call it, the world's augmented reality platform, contact me and I can hook you up with our SDK, and it will allow you to real easily, create your own augmented reality experiences using our platform. And that's it.
Ron, thank you so much. This, I remember you showing up and working with Colin a little bit on some of the integration points, and it's just a fascinating project, and I'm so happy that we can help out in a little way to what you're trying to do. But it's really, really a cool project, and thank you for taking the time to share it with us. I really appreciate that.
Well, thank you for NATS. And working with Colin has been great, because we had a few problems with Unity and we got them worked out. And so, yeah, it's been a great experience.
Yeah, no, and I know he was working with you, and I was talking with him, and he said, this is something that we don't think, we wouldn't have thought earlier on that NATS would necessarily be applicable to, but using your expertise and your domain expertise, and saying, oh, I think I can make this work well. It was really fun to watch. So again, thank you.
Yeah, this is an awesome project. Thank you, Ron.